All right, short video tonight here for you on rational exponents. These are just going to take a little bit of practice. The more you do, it'll be very easy, but it's a little weird at first. Probably not used to seeing them. What we mean by rational is a ratio, right? So a fraction, basically. You're going to see fractional exponents. You're going to see a base of something, x, y, whatever, and then you'll have an exponent that's going to be a fraction, 1/3, 2/3, whatever. So what you see on the screen here and on your paper are the rules, and with x's, m's, and n's and all that, it's kind of confusing. But just kind of look closely at the rule. X to the m over n, x raised to the m over n. It doesn't print very well. Like it almost looks like it's x times m over n, but this is supposed to be an exponent. It's x to the m over n. It's supposed to look more like that. It's an exponent, okay? So, for example, and don't have to write this down, but if it was x to the 1/3, okay? 1 is the top number, 3 is the bottom number. That's what they're talking about. X to the 1/3, x to the 2/3, all right? That's what it means. So what do? Well, here's the rule for rational exponents. It's just kind of a definition. The top number is the exponent. It stays as the exponent. The bottom number is actually a root. It's the root. So like if I said x to the 1/2, that's x to the first, which is just x, and the 2 is the root. So the square root, basically. Second root is the square root. So you would just write it like that. That would be the square root. X raised to the 1/2 is like the square root of x. If it was to the 1/3, it would be the cubic root of x. If it was to the 1/4, it would be the fourth root. If I throw a 2 up there, then I go x squared. Okay? And that's the kind of stuff we're going to be practicing. And you can see the rules right here. M is the exponent or the power, and n is the root. M is the power, n is the root. You can write it this way or this way. It doesn't matter what you do first. You could do the root first or do the exponent first. It doesn't matter. Another way of thinking about it is x raised to the power over root. Power over root. When you have an exponent when you have a fraction in the exponent, the top is the power, the bottom is the root. All right, so that's the rule. There's not really much of a lesson. It's just examples and how we're going to handle this. Okay, so here we go. Rewrite in radical form. If the number is rational, write it without radicals if possible. Okay, so 64 to the 1/3. We just said the 1 is going to be the exponent. The 3 is going to be the root. So it's going to be 64 to the first. And then the cubic root. The cubic root. That 3 is the root number. Okay, so cubic root of 64. Your calculator can handle this, and I'll show you in class tomorrow how to do that. You actually press the math button. You might want to write that down. Press the math button, and then it's choice 4. It says cubic root on there. So you would do cubic root. Now, we could do this, we should be able to do this in our head. The number times itself 3 times, that gives us 64. That is 4. That is 4. Or, we learned, okay, let's break this up. 64 is 8 times 8, right? 8 times 8 is 64. And then this is 4 times 2. And then this is 4 times 2. And then this is 2 times 2. And then this is 2 times 2. So I have a group of 3 2's. And I have another group of 3 2's. So 2 times 2 is 4. Okay, so that's how you would do that if you don't have a calculator. All right, here we go. This one, now, I'd throw in a negative in there, but that's okay. We learned negative exponents in a previous lesson, right? So we know this is going to be 1 over the cubic root of 25. 1 over the cubic root of 25. Okay, so that would be it. 1 over the cubic root of 25. And because we can't, that's just 5 times 5. You won't find a group of 3. And 27 to the second, and then cubic root. Now this one we actually can do. We can do the cubic root of 27 first. We can do that in our head. That's 3. So that's 3, and then squared is 9. Okay? And again, if you can't do that in your head, you can always use your calculator. That does come out to be 9. We wanted to make sure we write it without radicals if possible. Rewrite the following expressions in exponent form. Okay, so exponent form, radical 6 would be 6 to the 1/2. Okay, there it is, 6 to the 1/2. This is 4 times 6 to the 2/3. All right, it's not 4 times 6, that's not 24, because 4 is to the first. The 4 is not being raised to this 2/3. If you do 4 times 6, now you're putting that 4 in with the 6. Now you're raising that 4 to the 2/3. But the 4 is not part of the radical, and it's not part of the squared. It's not part of a cubic root. So the 4 has to be kind of by itself. 4 times 6 to the 2/3. Got it? And then here we go. -5 times 6 to the 1/3. Again, cannot multiply because the -5 is not part of the root. And then here I have 6 to the 2/3. 6 to the 2/3. 2 is the power, 3 is the root. 6 to the 2/3. Just kind of going backwards there, using our rules. All right, rewrite each expression in the form kx to the n, where k is a real number, x is a positive real number, and n is rational. Basically, get it out of radical form. All right. 27, now cubic root of 27, you could do that with your factor tree, but we already said cubic root of 27 is 3, just plain old 3. X to the second, but then the cubic root, so x to the 2/3. And then y to the 6/3, 6/3. Now, 6/3 is 2, so really we can rewrite this as y squared, because 6/3, so y squared. So there we go. Here, cubic root of everything, so we're going to do cubic root of r to the 6, so that's going to be r to the 6/3, s to the 9/3, over, we could do -64 to the 1/3, but that's just cubic root. I'm going to leave it just because I know I can take the cubic root of -64. That's going to be just -4. So I'm going to have negative r to the second, 6/3, s to the 9/3 is 3, over 4. And then I want to write it in this form. So it's going to be -1/4, -1/4 r squared s to the 3rd. -1/4 r squared s to the 3rd. This one here, I have 27. And I want to bring this up, so I'm going to write it as to the -1. I'm going to write it as, well, first of all, let's do this. Let's take the square root. Square root of 9 is 3, and the square root of x to the 4th is x squared. So I can just perform that right there, that operation. Those are perfect squares. 9x to the 4th, those are both perfect squares. So I know that comes out to be 3x squared there. Now, to write it in this form, we're going to do 27/3, which is 9. And then it's over x squared, but I want it to be in kxn form. Then I got to bring it up, basically, so that 2 becomes -2. So it's going to be x to the -2. Remember, whenever you move that from the bottom to the top of a fraction or vice versa, you change the sign, okay? All right, and then example 4, we want to write it as an equivalent radical expression. Simplify square roots only. All right, so this one will simplify. All right, so this is going to be to the 1/2, so it's going to be square root of 4x to the 5th, y to the 6th. Simplify square roots only, so we are going to simplify this one. Break it down. We already know that's 2. We know this is x, 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 and we know y, 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 y. So we have pair of x's, pair of x's, pair of y's, pair of y's, pair of y's. So this is 2x squared y to the third and then radical x. 2x squared y to the third radical x. This is just review. The new part is going from here to here, from the 1/2 to the radical, and then simplifying it, we should already know. That should be the review. That's why I went fast. All right, this is, we want radicals, so it's going to be x. Now, notice how the y to the negative 2/5, that's not part of the, x is not raised to that. The x is by itself. So it's like x times y squared, 5th root, and then negative. Now, I'm going to take care of the negative first. I'm going to make that x over y to the 2/5, because that got rid of my negative when you move it down. All right, so now it's x over y squared and then the 5th root. And we'll just leave it in that form. Just practicing the rules, okay? That could be simplified, of course, but we're not going to do that. And then this here, we just want an equivalent one. This one here, because it's negative, we're going to go 1 over the whole thing. 1 over x squared plus 1 to the 3/4. Now let's take care of the 3/4. 1 over power root. It's the 4th root of x squared plus 1 to the 3rd. See that? 3 is the power, 4 is the root, and we just leave the binomial. Don't worry about simplifying something like that. We just wanted to write an equivalent expression. Reason why is something like this would be like a multiple choice question, maybe on an exam, and you have to pick one of the 4 choices that matches. It may not be in simplest form, but it's equivalent still. Okay? All right, one more. Express in simplest form. This one's pretty easy. Get rid of my negative exponents by flipping it. So it's going to be m to the 9th over m to the 5th to the 1/2. Now, we can now use our our quotient rule, where we're dividing the m's. So you subtract the exponents. That's m to the 4th, still to the 1/2. And now we can multiply m squared. 4 times 1/2, m squared. And you're done. Or another way to look at this one, you could have done m to the 4th, and because it's to the 1/2, you take the square root. And of course, this is m, 2 pairs of m's gives you m squared. So either way you look at it, you can use that exponent rule or you can use the radical rule, and you're going to get m squared. See you in class tomorrow for some more practice on these exponent laws.